Welcome everybody to what will hopefully be an enlightening talk and workshop on Quarkus. We are very happy to once again be part of Internet Week Denmark. So before we get into it, I have a little bit of information to start us off. So here's the program for today. As you can see, we'll get through both an introduction to Quarkus as well as a workshop part where you can build your own Quarkus app. And of course, I would also like to present the organizing team. We have Henrik from Red Hat and Thomas from IBM on the floor today. You will meet them soon. And my name is Lida and I'm the community manager of Orbit Lab. So now that we introduced ourselves, it would be really nice if you would also introduce yourself to each other in the chat. You should see a slide window on the left side of your screen. And at the top, there are two tabs. One is called polls and one is called Q&A. And the Q&A tab is the chat. So to those of you who are not familiar with the Orbit Lab, I can tell you that we're a tech and innovation hub and an open community for everyone with an interest in digital technologies and entrepreneurship. We're based at Aarhus University and we're part of the Department of Electrical and Computer Engineering. And if you want to know more, you're of course welcome to reach out. Finally, we host a number of other events that you're all welcome to attend. In May, we have a couple more events coming up, and you can find the details on our website and our social media. And finally, as the program said, there will be a Q&A session towards the end, but you're of course welcome to ask questions in the chat along the way as well, and I'll try to keep an eye on it. Finally, if you have registered for this event, I will send out the slides tomorrow. And that's it from me. I'll now hand you over to the speakers, Henrik and Thomas. So take it away, guys.
Thank you very much. Allow us to do a very quick introduction of ourselves. I'm Thomas Pershanti. I work with IBM. I work primarily in the financial services sector as an IT architect. Been doing my time in software development for quite a few years, and my heart is quite close to Java. And I am delighted here today to introduce you to Quarkus, which gave even more love and care to my passion for Java. Henrik.
Yes, thank you, Thomas. I'm Henrik. I'm a senior solutions architect with Red Hat, and I focus on all of our products related to application delivery and application development. And a lot of these days are surrounding cloud native development as such, where Quarkus is right in the middle of that. So I help our customers navigate that and make the best of it.
Cool. So I'll share my screen here. So as Lida introduced, we will keep this in two forms. So we will be doing some slide things here in the beginning, where Henrik and I will introduce you to Quarkus and the upcoming workshop. So the second phase of today will be a real code along workshop where you can get access to some pre-provisioned environments that we've set up. So you can code along with me and Henrik on the screen to build your first Quarkus app. So without further ado, let's kick it off. So Henrik and we're here presenting the Red Hat and IBM message. As you know, Red Hat develops a lot of products and offerings out there, and everything is, and I literally mean everything, is developed in the open. It's all open source. It's driven partly by community. It's driven partly by Red Hat. And on screen here, you see a bunch of the most famous projects sponsored by Red Hat. I linked to the full list of projects below. And today, as we are gathered here to talk about Quarkus, you are, of course, free to open the GitHub repository for Quarkus directly. Just open the link you see on screen now, and you can basically tackle along. You will find, of course, the source code for Quarkus in there, and you will also find exactly the same workshop material that we will be going through at the end of today. So just follow the link. Anyway, Java. So traditionally, customers built these monolithic apps. So the whole stack was optimized for running many, many apps on one application server. You can see some figures here on the screen from the late 90s on how a cost picture could look like in a scenario where you were to deploy some large application servers based on beer, WebLogic, and a bunch of database servers. And as you can probably see, the cost picture is a bit different than what we see today in a cloud native and microservices and serverless event-driven architecture that most of us are doing today. It also has some implication on the operational model on how we develop Java, how we operated Java going forward. Because historically, the Java stack consisted of this application server running multiple applications. Over the past 15 years, we've seen this whole stack evolve, having an operating system below, a virtual machine on top of it. We would even run application servers, and we would use a bunch of more or less dynamic application frameworks, the likes of Spring, or we would be using something like structs or whatever back from the 90s. And this stack had a lot of implications, of course, in terms of memory. It wasn't unseen to consume just 1 gigabyte of memory when we started up. And the startup time for applications in this world was, on average, at least 10 seconds to start up. And remember that, Java is actually a rather old thing in a technology context. So take a look at some of the major points here from, let's call it computing history. And it goes all the way back to the first inception of Java 1.0 in 1996, where I just realized when I prepared for this, I didn't even join high school in 1996. I was in primary school. And you see, Java actually has been quite fundamental in many of the initiatives that you see on screen here. And one of the reasons is, of course, Java has a lot of developers out there. It is absolutely still the #1 language being taught in computer scientists or for object-oriented programming languages. And there are still many enterprise applications out there in the field. So obviously, what you've also realized is that the prices you saw for the hardware specifications for this huge application server stack and database server, this has changed quite dramatically in the last 10 years. The consumption services has evolved. One can rent cheap compute power at the fraction of $1, right? And Java obviously had to adapt to this new world to stay relevant for developers and enterprises. And I believe the first evolutions that we saw is what you see on screen here. So we did remove the hassle of the operating system and hardware, and we started deploying on the likes of Kubernetes and Linux-based containers. So as we started scaling this up horizontally, as opposed to a vertical stack like you saw on one of the first slides, this also had some implications that we had to start deploying our applications in smaller components. And this, of course, puts some requirements on low memory footprint and faster startup times. A sort of go hand in hand with this decomponentation and microservices kind of thinking. And the initial evolution of Java in late zeros actually did quite some enhancements here, but we're still left with this relatively heavy Java virtual machine, as you see on screen. Of course, it was even more performant than it was in the 90s, but unfortunately, it came with still a high cost in memory and somewhat slow startup time. So we did improve, but not to the extent that we would actually like. This is where Quarkus comes in, and this is what we'd like to introduce today. So Henrik, he will talk a lot more about the inner workings of Quarkus as a stack per se. But Quarkus essentially gives us the startup times and low memory footprint that we were asking for. So by making the JVM, the virtual machine, actually optional and optimizing the application frameworks out there. So picking the best of them, optimizing them to Quarkus, you get milliseconds in startup times and a very, very low footprint. So in essence, this is Java for containers, reborn for cloud native applications. And there's no doubt that the need is there. So with the ongoing shift to serverless stacks where you use functions, function-like programming in Knative or AWS Lambda or Apache's OpenWhisk project, you clearly see in the various surveys and analysis that Java is losing traction and it is being rejected in favor for languages and frameworks and technology stacks that address the very things that I just talked about in terms of startup time, speed, memory, and flexibility in choice of frameworks. And with a staggering low 6%, it is pretty obvious that Java is not chosen in many cases, and Quarkus is here to change this. Because of course it doesn't make a lot of sense to spend all your money on startup time and expensive quote unquote memory. Because Java was originally not really, built for this. It aimed to minimize network throughput for the most demanding apps of the day, right? It was designed for throughput, and that of course came with a penalty and an expense of footprint. So you sort of ignored back in the 90s and in the early 20s that we had plenty of hardware capacity available. So who cared that it took tens of gigabytes of memory and it took 20 seconds to restart, because we had other means to accommodate in this. And we also, designed things to be long running. That was sort of the notion and the architecture of Java apps. It was about maintaining critical customer data. It was about having user experiences that lasted for months and years at a time. It was business process management at its best. And we actually did our best to avoid that, to restart our applications. And so 10 minutes boot times were pretty acceptable, at least to operation teams. But again, this had the expense of startup time. And in a cloud native world where you deploy maybe even 2-3 times a day, you can't live with these startup times. You need something much, much more granular. So in the early days, we saw this development of frameworks, and we saw this rich dynamic behavior built from mutable systems. And we designed for something else back in the days. We used a lot of frameworks in the Java days to keep everything flying on the air. So think about changing classes during production time, and even, I would say, God forbid, the notion of using reflection capabilities in production systems. And with the rise of cloud computing in containers, we have to change this behavior in the footprint, because containers are actually thought to be immutable. They are thought to have a low life, so to say. We'll destroy them very soon, and then we'll just restart them again when we need it. And this is how we scale our stuff up. So with this short introduction, Henrik, over to you. And
sorry to interrupt. I have a little question from the audience. Thomas, would you go back to the slide where you have the link for the repo?
Yes, I will. And we'll just keep it on for a second. There we go. It's github/quarkus.io/Quarkus. Okay.
Thank you for that.
I'll stop sharing. Henrik, over to you.
Thank you. Let's see if I can find it. It should be up now.
Yep, we're good.
Good. Okay. So yeah, Thomas was kind of setting the scene with Java being something that's been around for quite a while. I actually just read up yesterday on the birth year of Linux containers, and it seems that we were born the same year. So it's even older than Java, actually. But it did take some years for it to become popular. And it did leave us at a point where we had an engineering team with Red Hat that was kind of wondering what was the next way to go with the Java project that they were engaging with, because they were doing optimizations and trying to get it to perform better. And it wasn't really, I mean, they were gaining like a few percent in effect. And instead, one night, they kind of took the discussion in another direction and said, what if we let go of some of the key functionality that we're not even going to use when we're on a container platform? And that's where Quarkus was born, actually. So let me just see there. Yeah, so what they kind of decided on here was to have an open source stack to write Java applications. So shared with everyone. And when Thomas said that we're open source with what we do, we're actually not only open source, we're also upstream first. So we don't let anything into our versions of things. We always contribute into the open source projects, and then we make our product versions from there. But the premise of this open source stack was to make it cloud native. It was also to target microservices, because these are trends that go hand in hand. Cloud native is a lot about the self-service capabilities, making it easier to be a developer, making it easier to get access to those resources that you used to have a pretty long, sometimes, provisioning for. And then also, I mean, the upcoming of serverless was also a thing that would be something that they wanted to address. Now, the reason that it makes sense to actually do this with Java and not just give up and choose Python or one of the cloud native languages that has come, like Go, is that there's actually a really solid foundation. Thomas also spoke about this being a #1 language when it comes to object-oriented programming in educational situations. There's the whole JVM that has more languages than Java, which also makes it really sticky with developers and allow for a lot of flexibility. So it's really popular. There are a lot of developers that already know Java, basically, and are ready to jump into it. Now, with the opinionated choices that were made, it was possible to do a reduction in the JVM mode, or the non-native compiled mode, which was this kind of the way that other Java applications were running. And by doing that alone, gave optimizations that were noticeable both on developer computers, but also when running in cloud environments. But going a step further and doing a native compilation actually boosted that performance into exceptional levels that makes Quarkus compete with the fastest of the frameworks out there for cloud native computing. So moving along, the toolchain has been developed around those tools that target Kubernetes platforms. So since this is an opinionated stack, an opinionated framework, it also makes sense to make sure that you have that toolchain that allows you to generate projects for cloud native or Kubernetes native development, IDE integration to handle deployments and debugging, local and remote, either case. With that, and Kubernetes is a great abstraction platform to do this, because it's deployable among all sorts of public clouds as well as in your own data centers. So you're actually getting those cloud native benefits within your own data center. So cloud is no longer about someone else's computer. It's about self-service for developers. It's about having an infrastructure that responds to your demands whenever you need it. And then lastly, one important aspect of this as well was that there's a broad ecosystem of different frameworks that were possible to draw upon for Quarkus as a Java framework. So you have all the classic things like Hibernate for your object relational mapping into the database. You have Kafka for streaming. You have Camel for integration, and all the surveillance tools around Jaeger, Prometheus, and Istio that makes it possible to monitor and follow your applications or services when they're deployed on Kubernetes. And this list of extensions is just way bigger than the ones that are selected here. Another important thing that the developers that established the framework, they took into consideration when doing this was that they wanted to address some of the things that were annoying them on a daily basis. So one of the examples I've seen in one of the presentations from the core team is how they took the stack trace, which is the error message you get when something fails, and they reversed the direction of it because they found they were always scrolling. And it's such a small thing, but still, it's been years and years of scrolling to find that position of the actual interesting message in your stack trace. Among these things were also something like having, basically cheating a bit and using that super fast startup time to do a live reload constantly whenever your code changes. This is something that when you look into Java, there have been products at the price range of thousands that solve this issue for you, doing live reload of your code whenever your source code changed, then your application deployment would change. But utilizing the fact that Quarkus is really, really fast at reloading or restarting, you actually get this feature right out of the box. And then something like making it standards-based, but then again, not having enough guardrail around you that you can't extend it to where you want to go. And that ties really into, having that streamlined code for the 80% and then being flexible for the 20%. Making it easy for you to start and be efficient for a lot of your daily tasks, because these days with microservice development, a lot of it is REST interfaces, it's business functionality, it's maybe updating a database. It's not really that complex. So it makes so much sense to have it streamlined for those scenarios. And then just something like gathering the configuration in one file, right? It's a small thing, but it helps you maintain that overview and not having to think about what kind of plugins am I using, where do I find their config. It's all in the same file. So with that, let's just take a look at some numbers for some of the optimization results that have been gained from the optimizations that I spoke about. So what we have with the Quarkus and OpenJDK version here is we see that comparing to some other traditional cloud native stack, we're about halving the memory consumption on this, meaning that we can actually have twice as many applications or services running on the same Kubernetes node, the same cluster node, the same infrastructure. You can have twice as many just by switching to Quarkus. And that optimization is actually on a compile time, looking at what is needed and then cutting away. If you see that this is not going to be needed, we're going to cut that away. So it's really simple. What you have on your far left, though, is way more interesting when we're talking about deployments, because we're at approximately 10%, and this figure varies a bit. So sometimes it's maybe 15% of the original figure. What we found is that in average, you can have an 8 times thicker density on your infrastructure node, which is pretty significant, especially in a time where the tendency is towards splitting your deployments or splitting your source code up into different code bases. So you're reducing the overall overhead. You're reducing that per deployment, and that makes a lot of sense when you have more deployments. Moving on to this next example, we're including startup times. And what we see here is that we're not only twice as fast on the OpenJDK version compared to the traditional cloud native stack, we're actually over 4 times quicker than we are in the traditional stack. So this is what can be used in that live reloading that you're also going to be seeing in the workshop. But taking that even a step further with the native compilation that we have as a feature as well, you actually reduce it to 14 milliseconds, which is what makes Quarkus really useful on the container platform. So one of the important features on a container platform, we heard how Thomas was speaking about maybe you do deployment several times a day. But this is not only useful in relation to doing deployments, it's also useful whenever your workload is being repositioned on your cluster, because if you have more nodes, maybe a node is updating underneath you. Maybe a node has problems and the workload needs to be rescheduled. Or maybe you have auto scaling enabled so that whenever you have an increase in load, you have more pods available, more services, more instances available for you. And that can, that works best if your infrastructure and your services are responsive and are available really quick whenever it's needed. And it's also essential when we talk about serverless workloads, of course. One thing that I didn't touch upon, but was actually listed in the developer joy section of this, was that with Quarkus, you can have both reactive and imperative code in the same code base. So reactive is something that we've seen gaining in popularity because of its capability to handle parallel workloads and to be responsive with an enormous amount of information coming through. So async programming especially is a use case for the reactive way of developing your applications. And because Quarkus has a core that is reactive, you can have that combination in your source code with both reactive and imperative programming. I've included some resources that will be available. This is mainly for the slides after, but code.quarkus.io is the project generator for the open source project. There's a product version also from Red Hat side, but that should be Googleable. And we also have some online exercises that are available afterwards that can be accessed at the Try Quarkus link. But with that, I am going to go into the workshop that we're going to be doing today. This is a workshop that would usually require a bit more time. We're going to be working with it for about an hour, and then we're going to do a QA session. So that's kind of the time frame that we're working on today. What I would like to say is that it's going to be available later today. It's going to be available until sometime tomorrow, where it's going to shut down. So you will have time after if you don't get completely through it within the time limit that we have today. But what we're going to be covering is kind of the basics around Quarkus. So checking out a project and seeing some code there. There's going to be a RESTful interface. We're going to do some dependency injection. We're going to see that live coding in action. So even though we're going to be working in an IDE and we're going to be working on an OpenShift cluster, it's still going to be local live app servers that are going to be running in those containers that you're working on. So it's kind of meta, but wrap your head around it. Your IDE and your workspace is no longer on your own desktop. It's actually in the cloud as well with the container deployments that you're going to be doing later. So other than the dependency injection, we're going to be looking a bit at unit tests because we need to do that, of course. Then we're going to be using that online IDE to do debugging as well. We're going to be building cloud native, not cloud native apps. We're going to be doing native compilation to do native apps. And then we're going to do the cloud native apps, and we're going to deploy it all to OpenShift and see that in action as well. So you're going to be seeing a couple of interfaces today and some different things. What you basically need to be doing this is you need to have a Chrome or Firefox that has a pretty recent update. If things get weird, we do have a few things that we're going to walk you through. But first of all, try to reload your browser. Otherwise, speak up in the chat. We're going to be monitoring that. We're going to try to troubleshoot as best we can. But usually...
chat, Henrik, sorry to interrupt, but we do have a question from Jens.
Yeah.
He's asking, was language choice for Scala removed? I only see Kotlin now as an option.
That's a really good question. I need to check up on that. I will set off the workshop, and then I'll follow up on that and see if I can find that question for it, because it's nothing that I've been working with that recently. But coming back to the workshop, we're going to share the URL for the workshop, so don't start typing the URL that you see right now. This is just to say that the source code is available afterwards. You will be having unique logins. This is going to be provided for you. And this is where I take you to this next slide. So the email address that you type here is simply for identification purposes. If we do have any issues, we can log into an admin portal and we can see whatever you entered there. It's not something that has to be a valid email address at all. You use the OpenShift password or the password OpenShift for these, and you do that as well when we get into the actual user interfaces. It's going to be the same across the cluster. It's provisioned like that. But what you get when you enter this and press submit is you're going to get this next page. And here you're going to have a specific user assigned to you. So this may be user 5, 10, 12, whatever. The password is the same for all of you. It's going to be OpenShift. And what you're going to have then on your right-hand side, actually, let me just switch over to the version that I have. Here I am logged in. I got user 2. The password is OpenShift. And when I click here on the module that says Basic Quarkus Development, you get the workbook. So this is what you're going to be working with during the workshop. And what you have here is you have the different sections on your left-hand side, and you have the instructions in the middle. You should be seeing your user ID already up in the top. If you don't, there should be a login prompt for you where you can use your user, the one that was assigned to you, and the password OpenShift. You're going to have instructions here. It's going to show you that you can click to copy some links to the different versions of Quarkus. And then you're going to be able to access your environment. What's important here is that some of these links are product links, so they're going to take you to the product or project pages, and others are the instance links that are provisioned for you. So here I have the access to Code Ready Workspaces instance. Now, if I click on that, I'm going to be in the web-based IDE that we're going to be working in for the majority of today. This is a web version of... Sorry about that. It seems like there's a digital assistant that wants to join in. But this is a web version of Eclipse that is deployed and provisioned on the OpenShift cluster that we're working on. This is the page you're going to be starting on that shows you some different possibilities of creating a workspace for you. But over in the left-hand corner, you can find the workspace that has been pre-created for you. Clicking on that is going to load it up for you. You're going to have a file explorer just like you're used to in an IDE. Here on the left-hand side, you have source highlighting. You have the option of having some tasks or commands available on the right-hand side. And generally, the instructions in the workbook are pretty good. But I am going to highlight some gotchas for you. First of all, if you get prompts all of a sudden that you're not prepared for, check back in the instructions and see if there isn't an explanation once you just browse a bit further, because in many occasions there's going to be that instruction that tells you what to reply with the different prompts that we have. What I would also like to tell you before you go ahead is that if you do use these tasks in the right-hand side, be careful not to click several times on this, because if you do that, you may actually end up with multiple tasks that compete over the same ports, and that can make the environment stick. I'm going to show you shortly how to resolve that if that happens for you. But press once and be patient about it, is my advice when working with these. And another kind of gotcha that I've experienced when I'm running these workshops is that some of these actually start, one of these actually start a terminal that you can use and where you can type things. I'm just going to click it for a good measure here. Now this is going to launch a terminal here in the bottom where I will be able to type all of the Linux commands that I'm used to when working in an operating system like this. Whenever we run the other parts of this, like the login to OpenShift, actually this is actually a good thing, because I am in a situation where my environment is actually stuck. So I'm going to show you how to resolve that. First, you need to open the overall menu again, which is in the yellow arrow section, top left corner. What I'm then going to do is click the workspaces. I'm going to go in the right-hand corner of that, or right edge of that, open that three-dotted menu and click Stop Workspace here. So this is going to stop it on the cluster and not just, in my browser reloading things. I'm shutting it down on the cluster, and then I'm going to start it again. So right now we're doing a reboot of my workspace, and when I go back here in the left-hand side to it, then it's rebooting. This is going to take a minute or two, but then it's going to be up and running again, and it's going to be ready for you to go ahead and work with.
Okay.
Yeah, right now, let's just get people on the URL for the workshop.
Yeah, sorry, go on.
No, take over.
Yeah, so in essence, if you tap in ibm.biz/Quarkus workshop, you should be greeted with a screen as the slide just before the one on screen now, where you are asked for your email address, and then tap in password OpenShift, and then you'll get a user assigned. And if you're thinking, why didn't they choose just the short name Quarkus? It's because I realized yesterday that it checks for trademarks, and Quarkus is a trademark. So I couldn't create that one. So anyway, So for the next period of time, I will be not requesting control. Sorry for that, but I'm gonna be sharing my screen, and then I will do basically code along. And Henrik is absolutely free to interrupt me if I'm rambling. So Lita, just in terms of time, can you shout out something like 5 minutes before we should enter Q&A?
I will do.
You will do. Okay, good. So as Henrik said, this is where you'll end. You'll see I logged in. I was the first one to do it, so I luckily got user number 1. And if I open up the workbook, Henrik already talked about some of this. It will probably be handy for you to do click and copy. You basically just do it by clicking like this, and then you do the usual stuff for copy paste on your various operating systems that you're on. I'm on a Mac, and just as a short, very short caveat I'd like to mention, it is that for some obscure reason that I didn't figure out, when I was doing this on a Mac, you get 2 additional new lines in every copy, which is kind of annoying, but that's just the way it is. Let's just click over here and get started. So what we will do today is to implement a relatively simple service, and this service will of course expose itself on HTTP. We will do some testing and some examples based on that service, and then we will eventually repackage it for deployment into OpenShift, and you will see our startup time, and you will see our memory consumption going, let's call it gradually down as we move along in the workshop. So that's pretty cool. Okay, so
Thomas?
Yes.
Can I just interject briefly? Because there was this question related to Scala, and I can see when I go into code.quarkus.io that there is a Scala extension there. In the open source project, it is tagged with preview, but in the product version, there are no preview tags. So there is an extension for writing services in Scala.
Cool. Thank you. In the meantime, I logged into my code-ready workspace, and I opened up the workspace assigned to me as user 1. So we'll get the full-fledged environment up here and kicking. The first thing we'll do is to import the project from Git. It's available here. So once again, I'm just gonna select this, go to my IDE and do a git clone, provide the repository, and with a little luck, it gets populated over here. So I have the source in here, and I have a couple of scripts that is being used by the IDE to perform some of the actions that we have over here.
Thomas, maybe you should zoom a couple of times just for the audience. My eyes are perfect, so I can see everything.
Yeah, of course. Okay.
I think that's better.
Yeah, that's better. Good. That's we'll see how much it breaks. Good, and we'd like to stay on page. Sorry. Okay. So now that this is imported, we'll start by, you can see all the files in our code-ready workspace and so on. So let's open up a terminal window.
And this is where we actually catch up to what I was doing before, right? So no need for me to go share. This is what Thomas is showing, and this is where it's going to help you out if you do have a bit of patience and you just click once here. I mean, with the terminals, you can open several, but with some of the other things, you're going to end up in problems.
So I just did a check on whether we were on the right release, just to ensure that it will actually work when we get to the OpenShift part. And we are already on OpenShift 4.7, which is the absolutely shiniest and latest release of OpenShift. So far, so good. So let's open up some code. So the greeting resource over here. It's the wrong one. Hang on.
Yeah, I think you're doing a test-driven development approach right now.
Exactly. Thank you. Here we go. So I'll open up my Java file. And again, you know, there's not a lot of surprises when you open up this. Let's get semantic highlighting. And
just choose never for that one, because that's helping. It's actually helping Che navigate the things. So.
Yeah, it was just because your face was over the never button. There we go. Okay, so again, there's not really a lot of surprises to those of you who have developed REST services in Java. This follows the same notion. So the path for our endpoint is exposed basically, yeah, in the path notion, and we get the Logger factory available, and it reacts on the GET requests, and it produces text plain sent back as a hello. Of course, we could do whatever we want. So if you want to run this application and just let it start up, again, we can go to some of the start live coding over here, and it will launch the first build of this simple Quarkus application that we just built. And you can see over here that we have something listening now on port 88. Now I'm not going to open it up because I prefer to use the terminal over here. Blah 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 blah.
Can I just interject for those coding along that if you actually, well, you can see it in the guide as well, but if you do choose that open in preview, you're going to see the default web interface that you get from the Quarkus app, where they've also tried to add a lot of developer convenience, including a debug console in there.
So if I again then go to my open terminal, and I will deliberately try to use the same terminal as we go along, because else I'm afraid I'll screw up. I just did a quick curl, listening, of course, or asking on the listening of 88 on localhost /hello, which was the path that we chose up here. I get the result back as hello. So lo and behold, we've built our first Quarkus app that exposes this. And of course, I can, you know, open this up in a browser. I'm not really. Can I actually do that now, Henrik? Open up a browser just to check.
Yes, I think the web task does exactly that.
Yeah, exactly. There we go. So I open up like this, and I can say /hello, and we will of course get a new hello back, just like in the curl command. So far so good. Okay, let's go back to our lab. So let's try to show the reload capabilities in Quarkus. So I can basically just, you know, change anything. I'm just gonna say hello to, like this. Save it. Let's go over here. There you go. Real-time update. Everything is fully automated, and it monitors all the changes that I'm doing because I have the live coding running over here in the background. This is very, very nifty when you have to test things out. Okay, so let's take the first step in packaging our new Quarkus application in an executable jar file. We'll cover and get back to some of the native builds later on, but for now, we'll just package this for OpenShift. So we'll click Package App for OpenShift, and you can see the commands flowing through here. Again, if you look into more details in the in the lab material, you will see the specific commands that you can run. You can see that it has built successfully. It took 3 seconds, 0.6, and we should be ready. Okay, so now we actually have a jar file in here that is stored in /projects /Quarkus workshops, blah, 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 blah. Okay. So now we have a target directory also here, which I should be able to open. Yes, and you will see my jar file residing over here, just like it said on screen. So let's say we want to run this now. I'm a bit lazy, so to run this, I'm just going to take this full command where we expose it on a new port. And please notice this, because we will expose this on 8081, and we will say /jar, just like any other executable jar file that you would execute. So I go back to my terminal over here, which is not used. I'm just going to clear it off. And I'm going to...
And if I can just interject shortly here. This is also where we sometimes see that people kind of get confused, because the tab that Thomas is using right now is a terminal tab, but the one next to it, the one to the right of it, is actually just a log output. So sometimes people confuse this with the terminal, and they start typing in this and they think that the terminal is stuck. But this is not a terminal window. It's just a log output. So once you see the check mark, or you see that the task completed, or you're done with the live coding or something like that, you can shut it down and go back to what you were doing.
So I'm going to do. So, no, I don't want to do that. So what we can see here is that our jar file started up in 0.6 seconds, which is actually pretty fast, so to say. And we can of course use our browser here and say port. I'm a little afraid this won't work. It worked. No, it didn't. Is that because I said HTTPS, Henrik? I'm just going to do it in the terminal. I take the curl command.
Yeah.
I'm just going to get a new terminal.
Mm-hmm.
And here we go. So the curl command said hello to, which is exactly what we had up here. And again, our live coding is still working. But remember that this will, of course, yield hello to, because right now what I'm running now is a packaged executable jar. So we won't get the, of course, we won't get the the live coding capabilities in that. So I'm just going to do a Control-C on this one. So now the executable jar is stopped in this terminal. I'm just going to close down my second terminal so we don't get confused. Good. And this is basically what it says here in this. Okay, so let's try to do some dependency injection and try to add some stuff into our application here. Okay, so again, what we just went through, we added a simple RESTful Java application that we built with Java, and now we're gonna modify the application and add a bean, an additional class that we can use. We're gonna do that by creating a new file. We're gonna call it greeting service to Java. Just gonna close this down. So I'm just to be sure, I'm supposed to create it in org acme service. So I'm going to create a new file called greeting service to Java. And I, of course, get a completely empty file. And we will add this simple coding here. So I'm just going to do copy paste. And this is where the double lines comes in on a Mac. It's very annoying. So just going to do like this. There we go. So what this will do, this code, is that first of all, I don't know, Henrik, can you talk a bit about the application scopes? which is quite relevant in this focus.
Well, yeah. So the choice around scopes and context for beans are very closely aligned with the ones that you get from CDI, right? So an application scoped bean is something that follows the application lifecycle and basically is a singleton. So there's going to be one instance of this greeter that follows, lives with the service.
Yeah. It takes it fetches the host name of the cluster that it's running on, or else it replaces it with unknown. And if we inject this directly as a greeting, which we'll do later, it will take the parameter coming in as name and say hello, your name, from the specific host name that it fetched up. So relatively straightforward. Okay. So let's open up the greeting resource.java that we have open over here. And now we're gonna inject or use what we actually just added to our application. So above the hello method that we have, we're gonna add the code we have on screen here. So I'm gonna do 2 new lines, and here we go. Just gonna do Am I doing this wrong?
Yeah, I think you're missing the class. I think you wrote over it or copied it over. No, it's down there, right? Okay, so you need to cut that and put it down under the other get, or before the other get, right? So that it's in the class. Yeah, line 14, for instance, or.
Yeah, we can do it like that.
Yeah.
So we do it like this.
Yeah, that should work.
Now, just gonna do it like this so it gets a bit more. Okay. Good. So we added our things here. Now, obviously, we need to do a quick import here. This. So now it should be able to actually compile, right? Am I having... There's something wrong with my brackets here.
Actually, I'm thinking if the inject has been imported. Oh, wait. Well, yeah, I think we might be missing the inject still, but I actually think as well that there was a URL that was kind of in the middle of everything there.
So we need Java like this.
Yeah. And then, no, yeah. What's happening on line 36? Or is that the ID actually helping us there?
Yeah, that's the
Maybe
ID.
it is. Yeah. Okay.
I think we're there.
Yeah.
I think we're there. Okay. So, again, remember, this is live coding, so I should be able to just use my terminal here. And you see, instead of just calling /hello, I called /greeting now, which is the additional path and the parameter name. And I used the name Quarkus in my example here. So the host name was being looked up like this, very, very long. I'm not going to pronounce it. And so the expected output that we expected was hello from name from hostname, and this is exactly what it outputted. So if I said Thomas here, it will say hello from Thomas, of course, from workspace, blah 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 blah. Okay, so again, looking at the beauty of live coding. Yes, please.
No, if you jump back into the IDE, because when we're working with source code in IDEs, we're used to being able to have like formatting assistance for our source code files, so that we don't have to be bothered with that indentation. So Thomas, if you right click, you actually have a format document, and you also have the format selection. So choose the Java formatter, and it's gonna take care of it for you.
Oh, that's beautiful. Oh, I didn't know. Thank you. Cool. Okay. Let's take the next step. This is where it gets test driven. Okay. So time to look at some of the dependencies that we have in our application. As Henrik said, there's a lot of extensions, as we call it, in Quarkus available. So there's an extension for S3, there's an extension for Kafka, there's an extension for MySQL, there's an extension from DB2, there's extension for a lot of things. And all these extensions is pretty straightforward to actually start using. So in your pom.xml, there's a lot of things, but in here you will also see that we have a dependency on the Quarkus-REST easy and JUnit, which we'll start using in just a second, and rest assured. So these are all extensions that we're using in our application. So let's do a basic test, and there's already one provided. It's in the greeting resource test in/tests greeting resource. So I'm not going to dwell into too many details on this. It's, again, pretty straightforward with asserts and what have you. So, of course, it expects that it receives a hello, which, by the way, is not the case right now because I changed it to hello 2. It also expects the status code 200 to come out when we run the test. So let's add a new test. We will do that in greeting resource test.java. And underneath here, where we will add more tests, we're just going to take the brief test over here and add it in. So it will be fetching the right parameter name, and it will ensure that it will get a hello and then eventually get the name at some point. It will start with, down here, the example I used before was hello Thomas. It could be hello Quarkus as the other example. So this is how the test will actually behave. Again, there's Maven scripts put together in this package. And if I can just execute them over here as part of the tool set in the workspace. So if I run the tests, again, remember to only click once. It will run through it and run my tests. And there are even test failures. So we go up here. It did expect to receive hello, but the actual was that it was a hello free. So if I go over here, do this change and run my test again, it will hopefully succeed. I'm just going to close the old one. And tests were running, and it tested absolutely fine. There were 0 failures, just based on the live update that I did. So far, so good. Of course, when you, and there's some more information on this, as I recall it in the workshop material. All this is tied into the build and packaging process, and you can of course go in and disable this if you have such desires. It's not something I think I would recommend to do, of course, but you can do that. You can get into some nasty situations with conflicting ports, as Henrik talked about. If you remember to close things down in the right order, like I did, you won't have any problems. So you should be fine. You can do some injection as well here. So let's write a simple test that show off that you can do tests directly on the HTTP resource using this. So we'll right-click on source/main/resources/meta-inf/resources. So good. And we'll make a new file. We call it test.html. There we go. We're just going to take the very simple HTML over here and add it in and remove the annoying new lines. There we go. Just gonna close down the file already now. So we will now do a test that will verify that that in the title it should say testing with Quarkus in the HTML. So we'll create a new test under the Java and down here in test source test Java in org active. We'll call it static content test.java. Add a new file. I'm just gonna tap this in. It will do.
Thomas?
Yep.
Sorry, I'm curious. Are you using copy shortcuts like Control or Mac C?
Yep.
Yeah. If you just click it, I think that actually fixes the copy issue that you're.
Let's try that next time.
Yeah.
But I didn't get the impression actually that it will throw it in the clipboard automatically. But okay.
It does.
Okay. Okay. So in this test, it basically opens up a stream with based on the HTTP client that it gets automatically included here by the test HTTP resource import that we're doing over here. So that's in essence a HTTP client that we can use. It reads the byte stream and then it of course does the test and ensures that it actually contains title testing with Quarkus.title as we saw in the HTML file before. So if we now let's rerun all the tests to ensure that things works. Hopefully does. It does. It ran three tests, 0 failures, 0 error, and everything basically worked. And we can of course inject into new services and all that. I think if it's okay with everyone, I'm gonna skip to some of the more interesting stuff. We have debugging capabilities as well in here, but I'd like to get to, in the interest of time, to build the native Quarkus app over here. You can of course attach debugger. As this is running live, it's pretty straightforward. Standard IDE, click the play button and you can do step by step, and you can insert breakpoints just like you used to in any other IDE, and of course do inspection on call stacks and memory and what have you, and variables. Again, as Henrik said, you will have the environment available for at least something like tomorrow noon. So, you know, feel free, absolutely play around, and you can find all the material on GitHub if you wanna play around on your local machine. But now let's try to produce this as a native executable with GraalVM. So we're just gonna, it should be installed, and just to ensure, I just clicked it, just to ensure, sorry, that we have Graal available. No, it's the same, Henrik. It makes 2 new lines. Really annoying. Anyway, and we see that we have the Mandrill package available. Mandrill being the Red Hat sponsored open. Let's see if I say this correctly, Henrik. Please interrupt me if this is wrong. But this is the open JDK build of GraalVM supported by Red Hat.
Well, when it comes to support by Red Hat, I do have to make a small correction, because we have we take that project and then we modify it a bit into something called Mandrill. Yeah. So that we use that one for the support part. But for the open source, the project, they do use the GraalVM version for it.
Yeah, good. Again, back in the pom.xml file, you will see the definition that we actually already have a profile built to build this as a native image. And these are in essence the profiles that are being made available in the workspace tab for tooling on the right side. So in order to build this as a native app, it's actually just as simple as clicking build native app, and then it will fire off Maven and build this as a native app. So now we're going further than just the executable jar file. Now we're building a independent an executable that we can run independently. Sorry, Henrik.
Yeah, it's just, I know that this takes a while, so I was just going to use that time to interject that if you go back into the IDE and you hover over the tasks that you have in the right-hand side, you're going to see what command it's actually triggering, and you can see that it's a simple matter of delegating into Maven. So if you're running these things on your own computer, or you want to run them in the terminal instead, a lot of this is simply a matter of Maven package or Maven compile dev, for instance, for starting the live coding parts. But hovering is going to show you what commands it's actually mapped with, and it's a simple mechanism.
Yeah. And again, yes, this runs for a few minutes, 2 to 3 minutes, and we will get an executable that we can run in our Linux terminal when we get there. We're just gonna, I think in journalists they usually call this paddling. We're just gonna spend some time talking and mumbling.
Yes. For sure, this is where we see a lot of users using the JVM mode for development and sandbox purposes. And then when you're happy with it and you want to make sure that this is what you take to staging or production, that's when you start looking at the native compilation part. Maybe you even have like a separate build server to handle this, so you don't have to use your own computer for it, because it's not only time consuming, it's actually also very memory consuming. So if you have like bigger microservices, you may actually run into your own laptop not being beefy enough to run these build tasks. So yeah, this is definitely one of the aspects that you save for when you need it.
Yeah. Whoops. I can't do that. Okay, I'm just kidding. Yeah. So, Lida, are there any brilliant questions in the meantime?
If there aren't,
no, there isn't.
Okay, if there aren't any questions, maybe you could show them the OpenShift user interface. Just spend a couple of minutes on that.
Can do that. Mm-hmm. Did I screw up my password? Even though it's actually finished in the meantime. So let's go over here. It took 3 minutes to build, so we weren't exactly exaggerating when we said 2 to 3 minutes. So that's great. It was a build success. Let's just close it down. So in my terminal here, slash target. Oops. Let's do like this. So this is the executable jar that we created. Never mind the timestamps. It's running a different time zone that at least the majority of us are in. So this is the executable jar, and up here we have the native file that is now built for us. So if we want to start this one up, I'm just going to take the complete path here. So we're going to paste in as a parameter the HTTP port that we wanted to listen on being 8081. And if we start this up, you see this quite extraordinary startup time. And I'm just going to remove this. Hang on. And that was my, sorry. There we go. And you see that started up in 12 milliseconds. So this was the startup time of the native build, which is of course really, really, really fast. Just gonna go over here to check on the memory consumption. Let's just fire up yet another terminal to check over here. And we can see this is the process ID. So if I do like...
Well, the RSS is actually the resident.
That's the resident size. Yeah.
Yeah.
There we go. So it consumes something like 37 megabytes in memory. This one, right?
It's been a while since I converted those.
Yeah. Or is this actually kilobytes? I'm actually a bit in doubt. It is pretty significant.
It's megabytes. We're actually fortunately helped by the workbook, so it's megabytes that it's showing.
Okay, good. Which is of course way less than it would be if we were running this. So I opened up the tab over here, and I should be able to just say hello, and it actually responds with my hello. So all works and is running over here. I can just close it down with a Control-C, so it shuts down. Good. So, in order to, Henrik, would you do just a quick tour of OpenShift before we add in the health checking and so on? Would that make sense?
Well, sure. I can speak like a couple of words around this. What's important here, I would say, is that overall, right where Thomas is hovering, you have the choice to choose between the developer perspective and the administrator perspective, which is something that we added within the last year or something like that. So to make sure that that developers do have the things that they usually find relevant here. So you can browse the project, which is, I mean, if you're used to Kubernetes, this is a namespace and then some, including some configuration and some user and access management. You have the topology view, which is also pretty core in navigating what deployments you have. Right now, it's simply showing different ways of deploying things on the OpenShift cluster. The workbook will explain to you how you deploy. I think you actually use Maven plugins to do the deployment, but you can of course choose Git, you can use container images, you can use Docker files, and there's a catalog with different things that are already provided there. And then you have access to things like monitoring, the builds, there's an explicit section for Helm chart-based deployments, which is also one of the newer features that we have in OpenShift. And then, of course, the config maps, which is the way that you do cloud-native configuration. And if you want to have secrets as well, it's kind of the same thing, but just with an added layer of security in there. But also for having that configuration that is independent of your actual container images, which make the base of your deployments there. I think that's the quick tour of it.
Cool.
Learn.openshift.com is a great resource if you're more interested in anything related to OpenShift.
Good. So what we're going to add now is a small health checker that will be used by the basically by the monitoring piece of Kubernetes and here by OpenShift. So it checks on whether the service is alive or whether it has to restart the container and so on and so forth. So that's what in a Kubernetes world is called a health probe. So we'll need to add a small Quarkus extension to do so. And there's, as Henrik said, there's a Maven task to do so. And we're going to add the extension smallroot-health. So I'm just going to take this small command and go to my terminal over here and add it in. And we should hopefully give it a green dash that the extension small-ry-health has been installed. Yes, please do.
And these extensions are the same that are listed if you go to code.quarkus.io to scaffold your basic project for you. It's the same mechanism that's being used in the Maven task to add and browse the available extensions there.
So the extension is now added somewhere, here we go, in our pom.xml. So we see that this is now added as a dependency. So everything works. So this also automatically adds a simple health check into our application. So assuming that I actually still have it running, which I'm afraid I don't have. Can you scroll this? Actually, you can.
I can't remember, but let's see it fail. I mean.
Yeah, I don't think I have it running anymore. Okay, I do have it running. So I wonder where that tab went, by the way. But anyway, I have it running somewhere. So status up. It did it did no checks at all, but the service is actually running. So if you want to add an additional probe, so a better health check, we're going to create a new Java class called simple health check. In org acme people health.
Oh, and you have to go up. There it is.
Simple health check.java. I'm going to take the simple piece of code again. It's tagged as being part of a readiness check, and it implements the interface of health check. And it should respond with a simple health check being up and part of the build application scope. So if we do yet another test in our console, it fails. And is that?
Yeah, you accidentally added a C in the health check response class. So at the end there.
There we go. There we go. So now, instead of having an empty check, which I had before, I've now added a simple health check with the status up as being part of the checks that OpenShift will be performing on a regular basis. Let's add a bit of additional data into our health check. So we're going to add some custom data into our health check. Again, this could be utilization. It could be some numbers on your transactions going through your microservice and so on and so forth. So we're going to now create a small file called data-health-check.java.
Thomas, the Q&A session is scheduled to begin in 5 minutes. However, I don't think don't let that stop you if you have more interesting stuff. I think we can shorten the Q&A session a little bit.
Okay. I'm just going to take the input over here, the same code, and tap this in. So I get a more detailed health check response. It's very original health check with data. I saved it. So if I now, instead of just call /health/ready, I'm now going to call /health/live. I should be receiving, we added some data here being foo and foo value and bar value. So with a little luck, this is actually what we get back as our check when we probe the /live path for our endpoint.
And just to add a couple of words around the reasoning behind the live checks and the ready checks is that when you're on a container platform or a Kubernetes platform like this, it's going to help you make sure that your things are actually running, right? It's going to help you in directing traffic to it. So imagine you have 3 instances of this service running, or you have auto-scaling enabled and you need additional instances. So making sure that you're a good citizen and implementing these checks is going to make sure that your platform is not going to route traffic before you're actually ready to accept it, right? I mean, especially in the situation where you're running a Java framework, for instance, that takes more seconds to boot, you want to make sure that you don't have traffic routed until it's actually live and ready to do so. That's one scenario. And another scenario is that you may have an application that's actually live. So you don't want it killed. You don't want it rescheduled or restarted. But you also don't want to have any more load on it. So implementing something that can check whether you're ready to take more traffic and putting that in your ready check is going to help the cluster make sure that you don't get traffic if you don't want it, but also give that peace and quiet to actually execute the workloads that are already running there. So it's all part of being a good cloud native citizen on your cluster.
Yep, good. We're going to add now a few configuration properties that we will use later on when we actually deploy this to OpenShift. So in our greeting resource class that we used before, we're going to add a few fields to the class definition. So after inject greeting service, okay. So here I'm gonna put this down here, I guess, right? Yes. We just need this fixed. Did I copy something wrong here?
No, I think it's simply the pop-up for the option that's teasing you a bit.
Okay, never mind. I can do it myself. Java.util.option. Good. It compiles completely now. Good. So we'll modify the hello method now to use the injected configuration properties. So in our hello, we're gonna change this. We have it down here. Just gonna do like this. It will use the world parameters instead, which we have added up here. So it's gonna be used instead. So automatically Quarkus is using application.properties. So if we go to source/main/resource application properties, we were gonna add the two configuration properties in there. So we have them available. So source main resources, source main application properties. Just going to add them here at the very bottom. So if I now, here in my terminal, try to call the service, it uses these two configuration properties being hello and Quarkus and the asterisk. So this is now the output that we get. So with the new and changed hello method that we have over here. So far, so good. I think in the interest of time, I'm probably gonna skip the update of the test. Oh, never mind. It's pretty easy to just do. Just to be sure, it's supposed to say hello Quarkus. There's an asterisk. There we go. Good. some information about how to tap in configuration profiles in terms of production and in terms of testing and development is also outlined here. But I think, wouldn't this be the time if I start a build for OpenShift? Maybe we can do some Q&A from now, Lide, now that we have something like 7 minutes left, at least according to my clock.
We have 22 minutes left.
We have 22 minutes left. Okay, sorry,
Yes.
I thought we ended quarter past. Okay, good. I'm just gonna tackle along then and package this for OpenShift. Build was successfully. And this is again, it's just a jar file that is performed. So if we want to go over here and do the deployment to OpenShift, we already did the login to the actual the web interface that you saw here. But now we're going to start using the command line interface. So I'll hit over here the login to OpenShift. So this has been performed successfully. And now we're going to add the extension for OpenShift so we can deploy native images wrapped together completely for OpenShift deployment. So we're going to add yet another extensions being Quarkus-OpenShift. So we're going to run this small Maven script in my terminal. There we go. And checkmark extension Quarkus OpenShift was added and has been installed. So now we're going to go into our application properties and deploy and add in a couple of parameters that it will use in order to build this correctly. It goes along the lines of self-signed certificates that we actually want to deploy this after the build. The deployment target is OpenShift. It will do it based on the Docker engine, Docker build strategy, and we will automatically instruct it to add a route into OpenShift so it actually gets exposed. So in our application properties, we'll take these 5 lines and add. I believe I have it opened. I don't. So all this is added now. And we're going to do a build of it where we skip the tests and we build it for native. And this takes a little while. You can probably recognize that there's a couple of the same build steps this obviously goes through. I'm just gonna let it do that. So as part of the build, it should actually automatically deploy this to the OpenShift cluster that we have defined. So when the build is successful, I'm going to do a quick test using the OpenShift command line interface to ensure that it actually is being rolled out and installed in OpenShift.
Thomas, we have a question from the audience.
Please do.
Yeah, it's Casper who's saying, very cool platform and tools. I'm having some issues with the live coding task, hanging/not updating. And I had some port issues during the tutorial. What are the specs on the VM we're running on?
Well, we're running in AWS on an OpenShift cluster, so that's addressing the specs part. What I would expect to be the issue here is the port locking thing that I was talking about in the beginning. So clicking that yellow arrow up in top, choosing workspaces, and then close the workspace. I can show it actually if I just take over the screen really briefly, because we don't want to shut Thomas down right now since he's doing the build there. I should be sharing my screen now. And then up in the top left corner, you have this yellow arrow that will open the workspaces here. This is the workspace overview. So going over to those three dots in the right-hand side is going to allow you to stop the workspace, and then that stops pretty quickly. Then open the menu again, and then click Start in Background, and then click the user workspace over on your left-hand side. It's going to open up again, and the ports should not be blocking then. And you can continue your work. But that's one of the incidents that we sometimes do see, that it's not able to recover from.
Sorry, he's saying that it's working, just not updating as fast, and that he already reset it.
Interesting.
I don't know whether it would make sense to close down the tabs then and then restart the live coding task. I don't know. You probably tried that, Casper. I didn't have the problem though. Yeah.
Guess he's trying. There's a radio silence.
Yeah.
On the Slido.
In the meantime, I'm happy to inform that the build is now successful. You can see that up here it started deploying to the OpenShift cluster with user 1 project, which was the project that we had defined already over here. And lo and behold, I don't even have to use the command line interface, though I'll do it anyway, because you can see that the data is starting to pop in. It's running on 3 pods. It's with 1 route and with 1 service. But if we do an OC rollout status, you can see that people-1, being the name of our application, has been successfully rolled out to OpenShift. So it is actually running as it should. So if we do a new check on the service that is now running on our OpenShift cluster, so with a different URL, yeah, there's a lot of environment variables in play here, so I won't bother you with all the details, but the sum of it is that we do get a response from Quarkus on OpenShift from the right application that we have running here. So if we go to our OpenShift console and we take a look at the topology view, first of all, we'll see that our people application is running here in the middle. And again, remember that this was the one that was completely empty when we checked it before. It has the right application called people deploy here with 1 service called people listening on 8080. So just like we configured it. And on the monitoring, we'll get to that in just a second. Actually, we have it running here as a project as well. And you can see now statistics starts popping in. Now it's been running for a minute or something. You can see the secrets that we defined. So it's all good. It's actually deployed as we wanted it to be. So let's now add in the health checks that we did. So the ones where it said foo bar and foo value and that juicy stuff. I'm just going to do it with the command line. So we set a probe. We do it to application DC people. We add the readiness probe, and we do add the liveness probe over here. We set a period of how fast and how often it should actually check, a threshold, and the actual URL being /health/ready and there we go, health and live. So just like we defined it earlier on. So I'm going to go over here in my terminal and add it in. So we added 2 probes successfully, and it rolled it out. So if I go over here, click project, topology, and I click over here in resources. I see down here. Now, where do I actually see it? Am I supposed to see it in...
Sorry, what are you looking for?
Wasn't I supposed to see the live and readiness probes here?
Well, actually, the way that you can see it is that you don't have a warning for them missing.
Yeah, true.
By the way, Thomas, now that you're here, try scaling up, since this should be native and responsive, right? So go over to details and click the up button. So, I mean, even clicking it like 10 times, you'll see the pod spinning up and becoming available here as well. I think right now the UI is probably slower than the actual starting of the different pods here.
And we did see for a split second, we actually saw the status being inactive and now active. So it successfully checked the readiness probe. So it's live now. Yep. And that actually, I believe, now your face, Henrik, is actually covering my ability to click next again. There we go. That actually concludes the workshop and the lab that we have set forth. As Henrik said, you can go to the various URLs that you get in the slide deck tomorrow, and there's even more tutorials and workshops available if you want to continue playing around. So that's absolutely available. There are, for every extension that you will find on Quarkus.io, there are examples and tutorials for all of them. So it's pretty straightforward to start using all of the extensions. There are very, very good documentation and examples for all of it. So it's just a matter of giving it a go. So are there any additional questions? Because I think we are ready to wrap up.
No questions in the chat so far.
Good.
So, oh, hang on. Here comes one. Where do you see Quarkus having the biggest impact in the cloud ecosystem? Will it compete with existing platforms, or will it be the new use cases?
Well, I can comment on that for sure. The way that I see it is that it is taking all of those skills and experience that we have with Java developers and making that available for, I mean, in general, cloud computing, right? So, for instance, take something like AWS Lambda, serverless on AWS. Using Java for that would probably have you spending 95% of your the hourly rate that you're billed on simply booting. Then it's going to do 5% compute, and then it's going to shut down and wait for the next request, right? Using Quarkus and the native build there, is going to change that radically, so that you can actually start having something that's both responsive and much cheaper to run. And then again, talking about the memory consumption and the density, I would say especially when you talk about doing serverless and integration, you can have really lightweight integration deployments that, I mean, is not going to overload your nodes with overhead memory consumption, right? Decreasing the memory usage to around 10% of normal Java deployments makes it very competitive with the most modern languages being designed for the cloud native purpose right now.
So is it going to compete? Sure, it is. We hope, at least. But again, as Henrik said, I agree. I think it's going to compete on the premise that there's quite a few Java developers out there. It's a pretty trusted platform, right? We've been using Java for many years. So yeah.
We have another question from Casper, or comment really. Maybe you can talk a bit more about what has been cut from what a classical enterprise Java backend developer might want, bearing in mind that we have only a couple of minutes left before we have to wrap up.
Yeah, well, I can say one. You won't get reflection, by the way.
That is true.
That's one of them.
Well, yeah, I mean, basically, I don't know all the details, but it is those just in case features that Java has had that was traditionally used for those optimizations that you have over time, and you will have instances where if you're using a classic way of running Java, you may actually have a better performance going classic. Because of those long-running optimizations that Hotspot will be doing, it can become more performant over time in those classic scenarios. But when you're talking about containers, you have no guarantee on how long you're going to have your deployment. And actually, I mean, every deployment on an OpenShift cluster, Kubernetes cluster, is, I think it's around, well, I would say max 30 seconds that any service has by default to pack up its things and be ready to move to another host, right? So it is taking that new premise and cutting away all of the cruft in that regard for starters, and then of course the native compilation afterwards.
Thank you for that. So I think that we will, I'll just have one final check if there's any questions. Which there isn't, so I think we're going to wrap it up now, so Internet Week Denmark can continue with their great program. So as a final comment, I promised the good people of Internet Week Denmark to encourage you to fill in the survey that you find on the left side of your screen next to the polls, it's the polls tab that you have to fill in. So thank you very much, Henrik. Thank you very much, Thomas. And thank you all for being here. And thank you, Internet Week Denmark, for having us. See you next time.
See ya.